Thank you. What a lovely summer day, isn't it? It could as well be the one in 2014 when Apple introduced the next big thing on WebDC, which was, we all know, Swift. And I'm pretty sure everybody remembers that the developer community just exploded in excitement. Everybody wanted to learn more about this new shiny programming language, which was presented to us as flexible, versatile, a majestic creature. But after using it for a couple of months, years now, put your hands on your heart and tell me, have you ever felt that your expectation about the language didn't quite meet the reality? Or have you ever had the feeling that instead of this, what we really got was this? An immature, incomplete technology that resembled a bird, but it couldn't really fly because it didn't have any wings. And personally, I had this feeling a number of times in the past years, and I do feel it sometimes these days, depending on the topic. And we as developers basically can do two things about this. First is to go back to good old ObjC and wait until Swift becomes a mature enough technology for our purposes. Or we can ask ourselves a question, what can we do to make this bird fly? And the answer is building the missing wings ourselves. And this can only be done feather by feather. And the next couple of minutes, I'd like to talk about 3 of these feathers that I try to build so that Swift would fly better for me. All of these topics are somewhat related to unit testing because that's a topic that I think that is somewhat underdeveloped in current Swift, but hopefully things will change. So let's dive in. The first is mocking. How many of you are familiar with these technologies? I'm not sure if it's visible. Yep. So these are 2 of the great ObjC mocking frameworks. And why were they great? Because in just a couple of lines, you could set up a full-fledged mock object for any class of yours or of the system, and modify the implementation of that function, the behavior, return value, even check for the invocation that function received. And this was made possible by the ObjC runtime and the dynamic nature of the language. And all this is gone for now, in Swift at least. And if we want to create mock objects in Swift, then we have to follow other approaches. One of these approaches is called partial mocking, when you subclass a dependency and override the function that you want to behave differently. But the thing is that this is a dangerous technique because, especially in case of classes that are not yours, you cannot really know what the underlying implementation would do with the internal state of the class. So whenever you override one of these functions, then you have the risk that you might break some internal state in the class. So instead of this, the current best approach, at least it looks like, is using dependencies via protocols. And whenever you need a mock implementation for a protocol, then you just create a class, conform it to the protocol, and implement the functions yourself. So this actually works, but it's pretty manual. Like if you want to test whether a function was called, then you create a Boolean property and set it to true when a function is invoked. Or if you want a custom return value, then again, you create a new variable, set it to something, use it in the implementation. And if you are interested about parameters that the function was invoked with, then again, you create a variable, do all this thing. And you could argue that, yes, that's what I do, works, what's up? But the thing is that if you have a somewhat more complicated protocol with more functions, then this implementation quickly becomes cluttered. And especially if you are multiple people in your team, and everybody has a different idea of how they would implement a mock of this kind, then it's really easy to run into a mock implementation that it's not obvious at first sight what it is doing or which variable belongs to where. And this was one of the issues that I encountered when working with Swift in my team, that we had these chaotic mock implementations that each one of them was a bit different from the other. And what I really wanted was something clean and understandable and readable and easy to use. And here you can see some of the requirements that I had for mocks, like what I wanted to do with mocks. Basically to control the return value of a function, track the invocations of that function, the same thing that I have just explained before. And I was looking for third-party implementations out there, but the thing is that none of them really convinced me for various reasons. And so in the end, I decided to roll my own based on a previous library. And my library is now called Mock6. It is an upgrade of the previous implementation, which is called Mock5. I'm very creative with names. And how would a Mock6 style mock look like? You would you would create a class that would conform to the protocol that you want to mock, and you also conform to this mock protocol, which is coming from the library. Then you would create an enum where you list all the methods that you want to expose on the mock with these cases. And finally, you go about and implement the methods that the protocol mandates by calling through this register invocation function, which is an extension on the mock protocol. And you pass it the appropriate method ID and the arguments that the function received. So by looking at this implementation, it looks somewhat clearer, but it's not immediately obvious why, what gains does it give you at the time of using it. So let's look at a test case where this is used. So this is a quick style test case. I hope you are already familiar with it. So using this mock at the beginning is pretty similar to using any other mock object. You instantiate it, you pass it into the subject under test. But here comes the magic, because the library allows you to modify the implementation of all previously declared methods keyed by this enum case. You can set a different return value. You can have side effects in this stub implementation. Basically, you can do whatever you want. And with the help of a nimble matcher library, which is companion of Mock6, you can also test the invocations that this function received. And there are some advanced matchers as well to test for the arguments that this invocation was called with. So after introducing Mock6 to the Resi desktop app testing code, we clearly had this win that now all our mocks are uniform and everybody knows what to look for. The chaos is gone, and everybody is happy. So let's move on to the second topic, which is code generation. Sticking with the previous example of mocks, I said that all our mocks are uniform, but this also means uniformity in another aspect, that they are all verbose. And if you imagine a protocol with like 4 or 5 or more functions to implement, I'm pretty sure you don't want to write that by hand. Luckily enough, there are some really cool code generation tools out there. One of them is Sorcery. I'm pretty sure you all know Sorcery. But to recap, it's Sorcery basically scans your Swift sources and extracts the type information in that sources, and it makes it available for a template that you provide. And with that template, it can basically generate anything. Let it be Swift files, ObjC files, Markdown, you name it. The templates that Sorcery takes can be written in multiple languages. The most known is Stencil, which is similar to the templating implementation in other stacks like in Django or JavaScript. Here you can see an example of generating the all cases collection for an enum. Is most of the time it's useful. But the lesser known feature of Sorcery is that you can also write your templates in Swift. And why would you do that? Well, first of all, that's a language you already know. You don't have to learn Stencil. Second, Swift is much more expressive than Stencil is. And a huge win is that you also have all the Foundation APIs at your disposal. Like you can use anything that's in Foundation in your Swift templates. And when I first learned about this, and I ditched Stencil, and I've been writing my Sorcery templates in Swift ever since. By the way, you can look at this template and see it as a body of a function which makes the type information available to you. And then in the end, it just prints the results that you have been accumulating along the template. So I think you already know where this is going. So I wanted to generate the Moxie style mocks with Sorcery. And it might sound trivial, but in fact it wasn't trivial, and it had quite a couple of challenges. For example, if you recall that we had some return value in the mock implementation, then generating the return value in a mock means that you have to figure out what is the literal or that atomic something that you can return from a function of an arbitrary type. It is easy for an array, for example, because you just return the empty array, or you return nil for an optional. But what about a function that returns a protocol? So these were the challenges that I had to solve. But after some tweaking, I can proudly say that the template that ships with Mox6 is now capable of generating these literals for property initialization and also function return values. It can also make that enum for you that indexes the methods in the protocol. And there are some other nice features that it has. I also wrote a blog post about it some time ago. If you're interested in this stuff, then be sure to read it. And with that, let's move on to our last topic, which is legacy code. This is a screenshot of the GitHub repo of the Prezi desktop application about a week ago. For this, you should know that we started to use Swift when 2.0 came out, so a bit more than 2 years ago. And ever since, we write all new code in Swift. And as you can see, we are still only at 33% of the code base written in Swift, and the rest is ObjC. And this is just the main repository. And we have some other auxiliary libraries that are all also in ObjC. And if we add up everything, then it turns out that we have around 110,000 lines of code in ObjC compared to just 40,000 in Swift. So this is a huge amount of legacy code. And the problem is that you do not just simply migrate 100,000 lines of code from one night to another. And we have to live with this baggage, but living with this baggage is sometimes very painful. if you just think about the previous example where I wanted to generate some mocks for some protocols, but what if those protocols are coming from an Objective-C header? So if I wanted to try feeding these Objective-C headers to Sorcery, then it would outright refuse to generate anything because it cannot handle them. So what can we do? Is there a way to convert H files to Swift files? And the answer is yes, and you probably all know this feature. It is called the generated interface, and it's available in Xcode in this context menu. The problem with this is that it's kind of flaky. Like 7 out of 10 times that I want to use it, it generates an empty file for me. And the other problem with this feature is that it's only available in the UI, so I cannot automate it. So I was looking for a solution that would make this conversion in an automated and reliable way. And after some trials, I managed to come up with something which I named Bridgecraft, which is a command line tool. And what it does is that it takes an Xcode project, extracts the bridging header from the project, and with the help of source kitten, it generates the Swift interface for the bridging header. Source kitten is, by the way, the framework that powers Sorcery, Jazzy, SwiftLint, and other tools that parse Swift files and process the types. And so with the help of this tool, I can now generate a Swift interface for my Objective-C headers. And even though the generated interface is not compilable Swift, since it's just Swift-like syntax, but it's not Swift, Sorcery doesn't really mind and can parse it together with other Swift sources and make all the type information available to my templates. And with that, I can generate the mocks also for protocols that are defined in Objective-C, and I don't have to migrate them to Swift. So these were 3 of the sharp edges that I encountered by working with Swift, and I'm pretty sure there are more. I'm pretty sure you also have some. To summarize, I have some takeaway thoughts for you. And the first is that you can learn to live with the pain, or you can go and invent the painkiller. The second is that nobody else knows your problem better than you do. So if you look around and don't see a solution that's 100% suitable for you, then just go and solve it for yourself. And the final one is that don't be afraid to stand on the shoulder of giants. I mean, Mock6 wouldn't exist without Daniel Burbank's Mock5, the previous library that I upgraded, or Bridgecraft wouldn't be possible without the help of Source Kitten. So there are a lot of great frameworks out there ready for you to use them. And if you come up with something that is useful for others as well, then please consider open sourcing it and contributing back to the community so that everybody could use it. Because even though the Swift core team is doing an awesome job, but in my opinion, we have to work together to make this bird reach the sky. Thank you.